everyone, I hope all of you are doing good, and I am back with the second video of the video series on Gravitation Class 9 Science. Now in this video we are going to cover some very important concepts of physics like free fall, acceleration due to gravity, mass versus weight. So are they the same or they are different? So we are going to talk about some very interesting concepts of physics, and this is Roshni from LearnoHub, the free learning platform. So let's get started.
What do you mean by free fall of an object? Have you ever observed that when a person standing at the top floor of a multi-story building and he throws something, that object straight away falls to the ground, right? So that is known as free fall. That means an object is falling freely. It has full freedom to fall. That is known as free fall. So an object is said to be in free fall when it falls towards the surface of the earth only under the influence of gravitational force of the earth. That means the force of gravity is the only force acting on that object at that point of time. So the gravitational pull tends to attract that object and the object falls completely. This is known as free fall, right? So why are we talking about free fall? You will get to know very soon. Now during free fall, the direction of motion is unchanged because the motion will be along the same direction and the direction will be downward direction towards the surface of the earth. So the direction of the motion is unchanged. It is not that during free fall your direction will keep changing. Magnitude of velocity increases due to attraction by the earth. Now since the earth is attracting that object, therefore the object tends to move faster towards the ground. So therefore its velocity actually increases. That means there is an acceleration of an object which is under free fall. So a free falling object has an acceleration. And who is responsible for that acceleration? Gravitational pull of the earth. So that is why this acceleration of an object which is falling freely is known as acceleration due to gravity. So under free fall, we are basically going to talk about acceleration due to gravity. So take the example of a person throwing a stone from the top of a multi-story building. So there also the same thing happens. Once the stone is left from his hand, the stone directly goes off and falls to the ground. The only force acting on the stone is the gravitational pull. And because of the gravitational attraction, the velocity of the stone also keeps increasing. And since the velocity increases, that means there is a change in velocity with time. That means the object has an acceleration. So this acceleration is known as acceleration due to gravity. So now we will talk about acceleration due to gravity of the earth. So let us quickly look at the definition of acceleration due to gravity of the earth. It is the acceleration experienced by a body during its free fall due to the gravitational force exerted by the earth. As I mentioned in the previous slide, right? So during a free fall, what happens? The only force that is acting on that object is the gravitational force of the earth. So as a result, what happens? The velocity of the object keeps increasing. Therefore, the acceleration which the body experiences, that acceleration is known as acceleration due to gravity of the earth. So it is generally denoted by a small g. So often you have many people get confused with the two g's. There was a capital G which was the universal gravitational constant, and there is this small g. So this small g is acceleration due to gravity. So please do keep them separate. Never, always write small g for acceleration due to gravity and always write capital G for gravitational constant. These are two different things. They are talking in two different aspects. So when I talk of the capital G, it is the constant which is involved in the universal law of gravitation, right? So it has nothing to do with free fall. But when I'm talking about the small g, it is acceleration due to gravity. It is the acceleration experienced by an object during its free fall. Right? Okay. So now we will try to derive an expression for acceleration due to gravity. That is an expression for small g. Let us suppose that this person is standing on the top of a multi-storied building with a small stone. And let us say that the mass of the stone is m. Right? Now what happens when the person when he leaves the stone falls down. Now when the stone falls down, the gravitational force of the earth attracts it towards itself. So what is the gravitational force that is acting on the stone? Gravitational force is nothing but the weight of the stone which is acting in the downward direction, right? So the gravitational force which is acting in the downward direction is nothing but mg, that is the weight of the stone, right? Also, we know that the force of attraction between any two objects is given by the universal law of gravitation. So what are the two objects in this case? One object is stone and the other object is earth. So there is a force of attraction between the stone and the earth, and the expression is given by G into capital M into small m divided by d square, where capital M is the mass of the earth, small m is the mass of the stone, and d is the distance between the stone and the earth. Let us suppose d is nothing but the height of this building, we can say that, right? Now therefore we can say that this force and this force are equal. The force of attraction between the stone and the earth is nothing but the force with which the stone is attracted towards the earth. Therefore we can say that mg is equal to capital G m into m divided by d square. So m and m will get cancelled. So we can say that G is equal to capital G into capital M divided by d square. So this is the expression for acceleration due to gravity. Now if the object is on the surface of the earth, or it is very near, in this case this object was at a distance d from the surface of the earth, right? This is the surface of the earth. Now let us suppose if the object is on the surface of the earth or near the surface of the earth. In that case, what happens? What is this d? Now here this d is not the distance from this surface. This d is basically the distance from the center of the earth. That means let us suppose this is some height h. Okay, so there is some distance is also there from the center of the earth. So this d is nothing but radius of the earth plus the height. It is something like this. Let us suppose if this is the earth, so this is the surface of the earth. So from the surface the stone was at a height h, but already you have some radius r of the earth. So in this case d denotes the distance of the stone from the center of the earth. So that means d is nothing but r plus h in this case, right? Now if we say that the object is on the surface of the earth, if your stone lies already on the surface of the earth, in that case the expression of d becomes gm divided by d will be replaced by capital R, that is radius of the earth. So in that case g becomes equal to capital G into capital M divided by r square, right? So this is the expression for acceleration due to gravity of the earth. So now we will try to calculate the value of g on earth, because we derived the expression. Now on the surface of the earth, g is equal to capital G into capital M divided by r square. So g is universal gravitational constant whose value is 6.7 into 10 to the power minus 11 Newton meter square per kg square. What is m? M is the mass of the earth, which is 6 into 10 to the power 24 kgs. What is r? R is the radius of the earth, which is 6.4 into 10 to the power 6 meters. So putting these values, we can calculate the value of acceleration due to gravity. So it will be 6.7 into 10 to the power minus 11 into 6 into 10 to the power 24 divided by 6.4 into 10 to the power 6 whole square. So this value of g comes out to be 9.8 meter per second square. So this is the value of acceleration due to gravity on the surface of the earth, right? So wherever you will see that, now we will talk about the motion of, whenever we talk about the free fall motion of so many objects, we make use of this acceleration due to gravity. So because whenever an object is under free fall, the acceleration which is acting on it is this small g. So the value of this small g is taken as 9.8 meter per second square. Now value of capital G is constant. It is universally constant. The value will remain the same everywhere. But for small g, the value will not remain the same everywhere. For example, right now whatever we have calculated is the value of g on earth. That is why we have taken mass of the earth, radius of the earth, right? Now, if I want to calculate the value of g on moon, so the mass and radius will get changed. Therefore, the value of acceleration due to gravity will also change. So, the value of this acceleration due to gravity changes from place to place. It is not universal constant, right? Okay. So now let us talk about motion of objects under gravitational force. So how does the motion of objects varies when they move under the force of gravitation? So equations of motion, which we talked about in one of our previous lessons, right? When we were talking about motion, we talked about the three equations of motion. So those three equations of motion are still valid. So they are still correct. The only difference is that right now the acceleration will get replaced by acceleration due to gravity, because here we are considering that the objects are moving under the influence of the gravitational force. Now, since they are moving under the influence of gravitational force, so the acceleration which they are experiencing is the acceleration due to gravity. So the first equation was V is equal to U plus AT. So A was the acceleration, which is replaced by G. The second expression was S is equal to UT plus half AT square. So A is again replaced by G. The third equation was V square is equal to U square plus 2AS. So there also A is replaced by G. So other terms have their own values, that is U is my initial velocity, V is the final velocity, T is the time taken, and S is the displacement. Right? So we will still use the same kind of equations. Now here the value of g, when I talk of the acceleration due to gravity, it is taken positive when it is in the direction of motion, and it is taken negative when it is opposite to the direction of motion. Let us quickly take the example of the stone again. Okay, let us suppose there is a stone here. Okay, and the stone, you throw the stone from some height h. So the stone falls to the ground. So that means in this case, what is the direction of motion? The direction of motion is downward, right? So the motion is taking place in the downward direction. And what is the direction of acceleration due to gravity? That is also in the same direction, because the earth is trying to pull you in the downward direction. So both are in the same direction. So in this case, G will be positive. But if, let us suppose, if you throw a stone in the upward direction, so right now the stone is moving in the upward direction, so in that case the motion is in the upward direction. But what is the direction of acceleration due to gravity? The gravity is still trying to pull the stone in the downward direction, right? So, and because of the gravity, only after reaching a certain height it starts falling back. So in this case your G will be negative. So whenever an object is falling in the downward direction, G is positive. Where it is moving in the upward direction, G is negative. So we have to take into consideration this sign convention. Now that we have spoken about the acceleration due to gravity, it is very important to talk about weight. Most of us often consider mass and weight as synonymous. We often go to a grocery shop and we say that I want 1 kg of rice. So for us, that 1 kg is the weight of the rice, 1 kg is the mass of the rice. So many of us think that mass and weight are the same things. There is no difference between them. But that is a misconception. Mass and weight are two different things. When I talk about mass of a body, I am talking about the measure of inertia of the body. What is inertia? We have spoken about inertia in one of our previous lessons. Inertia is the property of a body to resist a change. That means a body at rest would like to be at rest. It does not want to move. A body which is moving does not want to come to rest. It wants to move. So mass is a measure of inertia of a body. It is an inherent property. It is a characteristic property of an object. Whereas when I talk of weight, it is the force with which earth attracts an object. As I told, right, as per Newton's universal law, every object attracts every other object, right? So earth as a whole attracts every object on it, which are present on the earth. So the force with which earth attracts any object, that force is known as weight of that object. Let us suppose if I say, when I say 10 kgs of potato, so that 10 kg is nothing but the mass of the potato. But when I say what is the weight of that 10 kg potato, that weight is the force with which those 10 kgs of potatoes are attracted by the earth. Correct? So when I talk of mass, it is a constant quantity. It does not change from place to place. But when I talk of weight, it changes from place to place. Why? Because when I talk of mass, I am just talking about the mass. That is 10 kgs, as I took the example of potato. But when I am talking of weight, it is the force with which the 10 kgs of potatoes are attracted by the earth. Now, what is the force? According to Newton's second law, force is given by mass into acceleration, right? In case of earth, what would be the acceleration? The acceleration due to earth is nothing but acceleration due to gravity. So weight is given by mass into acceleration due to gravity, right? So for the 10 kgs potato, what will be the weight? Weight will be 10 into 10 meter per second square. That will be 100 Newton. So 100 Newton would be the weight of the 10 kgs potato. Correct? So are you understanding the concept? So whenever I say weight, in science, weight is the force with which it is getting attracted towards the surface of the earth, and mass is actually the measure of inertia of a body. So when I talk of the unit to measure mass, it is kg. Unit to measure weight is Newton. Newton is the same as the unit of force. So mass is a scalar quantity. It has nothing to do with direction, but weight is a vector quantity because weight is nothing but a force. So force is a vector quantity, so weight also has to be a vector quantity. It is denoted by a small m. It is denoted by capital W, which is equal to m into g. So weight is actually dependent on mass. As mass changes, the weight of the body will also change. So I hope now you understood that whenever we go to a shop and we say that give me 5 kilos of mangoes. So that 5 kilo is nothing but the mass of the mango. It is not the weight of the mango, right? Okay. So with this, let us try. Just now in one of the previous slides, I told you that the value of acceleration due to gravity changes from place to place. Now, if the value of g changes from place to place, the value of weight will also change from place to place. That is quite obvious. That is why I told that mass will remain constant everywhere, but force will keep on changing. So here in this slide, we will see the weight of an object on moon. Let us suppose there is an object whose weight on earth is 10 newtons. So how will the weight of the same object vary on moon? So force with which the moon attracts an object is the weight of that object, right? Now we know that mass of moon is less than mass of the earth, right? Therefore, force exerted by moon will be less than the force exerted by the earth, right? Now let us suppose that the object has a mass of small m. Okay. Now let us also assume that the object weight on moon is denoted by Wm. Right? Mass of moon is denoted by mm and radius of moon is denoted by Rm. So what would be the weight of the object on the moon? It would be mass of the object multiplied by the acceleration due to gravity on moon, right? So this will be equal to m into, we find out an expression for g. What was that? It was capital G into m divided by r square. So this m is mass on moon and this r is also radius on moon. This capital G will remain same everywhere, whether it is earth or moon. So this is the value. So this can be written as g into m into small m divided by rm square. Now we know that weight of the same object on the earth. What would be the weight of the same object on the earth? It would be capital G into mass of the earth into mass of the object divided by radius of the earth. Let us suppose this is mass of the earth and this is radius of the earth. Correct? So now we know that mass of the earth is equal to 6 into 10 to the power 24 kgs. whereas mass of the moon is equal to 7.36 into 10 to the power 22 kgs. Radius of the earth is equal to 6.37 into 10 to the power 6 meters, and radius of this is radius of earth, and radius of the moon is equal to 1.74 into 10 to the power 6 meters, right? So putting these values in the expression above, putting these values in the previous expression, that means in expression 1 and 2. So putting these values in 1 and 2, we find that weight on the moon divided by weight on the earth is equal to 1 by 6, or weight of an object on moon is 1 by 6 the weight of the object on the earth. So that means whenever you take an object, so if you have an object whose weight on the earth is 10 Newton, when you take it to moon, the weight becomes 10 by 6. So this was another important thing to notice here, because the weight varies as you move from one place to another, because the acceleration due to gravity varies.
I hope you found the video useful. Please let us know your feedback in the comment section, because your feedback is important to us. I will meet you guys very soon with a new video, with a new topic. Till then, take care. Bye-bye.